I'm now going to shift gears for a minute and talk about how this happens in some ways. Our work, I'm going to focus on what we do at Esri, creating useful technology and supporting you, our users. And this is largely focused around ArcGIS. ArcGIS is considered by us and by you as a complete integrated GIS platform, a system for managing all the information as I described before. And it's been engineered as an open platform, services-based, now fully services-oriented and distributed. It's available on your own machines or in the cloud, or also available as SaaS. And it's designed, the intention of the design is to support individuals and teams and organizations. Now, I've gone through this whole slide describing it carefully because we've thought a lot about this. It's like designing that platform is a huge engineering feat. And I'm very proud of the people at Esri who do this. They take this notion of an integrated, complete platform very seriously. And they are guided by you. They're constantly searching for input. And during the week, we'll see lots of interactions. And I want to invite you to, in a way, criticize us and share ideas about where we should go with this platform in the future. Now, ArcGIS organizes and manages all aspects of a GIS. And quite naturally, it's the data, but it's also the information products created from the data, the maps, the web layers, the scenes, and also apps and models, and also the people and organizations. Portal is used as a technology to provide a common integrated user experience to bring these different items together. And ArcGIS supports multiple implementation patterns, the desktop, the server, the new web online experience with Enterprise and ArcGIS Online. And this new distributed pattern, this system of systems pattern, is about integrating the other patterns to connect everything. That's the idea. You get the idea? As long as we're stopping for a moment, I'll just share with you that all my notes are on my hand right here. If you haven't noticed that, I keep track of them. It's my way. All right. Next, I'd like to go on and talk about some of the ArcGIS capabilities that we're advancing. And here I'll be sharing things that we've been working on in the last year, give you kind of an update on a whole series of frontiers. We'll start off with ArcGIS content. We now see ArcGIS content available in ArcGIS Online as a fundamental part of the platform. We have thousands of ready-to-use data sets, maps that are really empowering many of your systems. In some ways, this is a little underutilized, so I want to send you a message that take a look at this, because these are data sets on imagery and base maps, the most powerful ones that you use, but also on demographics and boundaries and just a whole plethora of different topical information sets that may be useful. And also there's this other phenomena going on, which is millions and millions of maps and data sets have been shared by you for other people to use. So there's this growing ecosystem of content. I guess the way I would describe it is the foremost collection of global geographic information on the planet. And it's growing every day. Another way to describe it is, my good colleague Clint Brown says, it's a living atlas. And increasingly, as information like real-time imagery is coming into it, we're seeing a very vital piece of the platform emerge, which is content as services available for everyone. The core part of a GIS, as you all know, is data management and compilation. And here we're advancing data models, for example, the new utility network model, Also adding new workflows and tools, improving editing. For example, new stereo feature extraction directly in Pro, and the ability to automatically register new imagery using the global imagery background. And new tools, for example, tools for CAD integration, tools that allow us to register CAD drawings in a GIS and interoperability between CAD and BIM environments, and also working closely with our colleagues at Autodesk Corporation, building all kinds of interesting interactions between our respective tools. And then there's the world of faster, more accurate, global geocoding and location finding. Tools that many of you have asked for are now in the platform. In the world of field GIS, I already mentioned it, we're taking GIS beyond the office. And many of you already use Collector and Survey 123 and Navigator to find your way around in Workforce. This year, we've released a new version of ArcGIS Online, which is all about taking maps to the field and being able to do markups in a connected and disconnected environment, and then shoot them back to the enterprise. This is all about connecting the field workers back with the core enterprise organization. Our work in mapping and cartography continues to advance the tools. For example, smart mapping tools I mentioned already earlier are improving not just with 2D cartography, but 3D thematic representations. And you'll notice the very fast display that's happening here. This is something that's still in development, but coming out later this fall. In the Pro space, we've added new tools for cartography, measured grids, multi-scale drawing, and dynamic charts and layouts, something that many of you have asked us to put in. Production charting, mapping in topo, aeronautical, nautical, these tool sets are also progressing nicely. Some of you are interested in vector tiles for speeding up your display, and both in 2 and 3D environments, these are now supported, along with the ability for you to project your own vector tiles into your own projection. You're supposed to say, hey, that's really cool, right? Let's hear some applause. Took a lot of work. Okay. We've made progress in integration, and this summer with the Adobe Creative Cloud in both Illustrator and Photoshop. So now practitioners of graphic display can unite these two technologies together and work with them productively. In the 3D space, we now consider GIS as a common 3D platform for visualization and analytics. It brings in data sources of all types, going from BIM and CAD drawings into a GIS, from LiDAR into a GIS. This is, and so on. And this is extending the language of maps into a language of 3D GIS work. Our work here has also been improving the functionality in the area of visualization and new tools for urban planning and geodesign. The apps continue to advance for navigation in Pro, for visualization in Earth, and the new scene viewer with 2 and 3D visualization is very powerful. We've added new data types that can be used, for example, now supporting 3D objects and 3D meshes with the specification of I3S. And in the innovation area, some fun stuff like augmented reality. I've showed you some of that already, but also virtual reality, opening up new visions of GIS data to new audiences, and new cool tools in the animation, for example, what you see here in the lower left. We also consider ArcGIS as now a complete imagery platform with 3 major components. First, the support for all leading sensors. Big satellites, small satellites, air photos, multi-dimensional data, radar, drones. Second, dynamic image processing. This really means image processing on the fly. And no matter how many times I've explained this to users, many people don't get it. So I'm taking the time today to explain this. It means if you have an image and you pan and zoom around on it, it does dynamic processing. Instead of processing the thing and waiting until it's done and then using it, this just looks at raw imagery coming right off the sensor, and I can dynamically process it and analyze it. And what does it give me? It gives me many analytic, on-the-fly results. Traditional things like classification or NDVI, but also change analysis. And look at these interesting new things we're doing with something called image space versus geographic space. This may be a foreign idea to many of you, but to the photo interpreter, they want to see things in image space, even though it's kind of weird looking, and then dance back and forth between geographic space and image space. This means if I draw in one, I can see it in the other. It means being able to capture from a warped image in many of our views, digitize and see it right into our database. Okay, I'm geeking out on you here, but it's pretty cool. This dynamic image processing capability means that I can stick the software right next to large, massive image stores, like terabytes, dozens of very large image data sets in a cloud, and process the imagery on request, dynamic processing next to the data. This is really an interesting pattern. And the server serves out image services and pictures of the results in a second. We're already doing this with Landsat and have for a couple of years. Every night, the whole world is covered with Landsat, and we immediately stand it up in the cloud within a few hours, and people around the world are advantaging themselves with this kind of real-time, near real-time imagery. Same with SST, and more recently with NAPE. This fall we'll support Sentinel-2, which is the European satellite, multispectral satellite, and in a couple of weeks we'll be releasing global elevation for the entire world. All of these are inside of ArcGIS Online in this living atlas that I described before. Yeah, it's neat. And I'm very pleased today to make a new announcement with our partner, Digital Globe. We've teamed up to put image server technology right next to their massive collections all the way through time that they've been gathering. And you can subscribe to this process where you can go back in time or just last night's image and do analytics on the fly. All of those things that I was describing. It's pretty cool. In the area of spatial analysis, what Lauren was talking about earlier, lots of new progress. In web-based analytics, new tools for spatial statistics, like being able to do vector analytics in space-time cubes. This is a big step. This is Lauren's invention, and it's another step in the evolution of spatial statistics. Nothing like it's ever been done. And lots of other enhancements. The integration with science through the R integration and the ArcGIS API for Python, very powerful tools to connect us to the other communities. But for me, the most interesting one is this little one called improved processing. And here we're using the parallel processing capabilities of the new GPU technology to parallelize computation like on a desktop for raster analytics. This improves speed. And then also look at the one below it, models as a service. So if I make a cool model builder model, I can effectively right-click it, send it over to my enterprise server, and it immediately comes alive with a service that other people can use. This is going to change how we share our tradecraft in the spatial analysis world. Yeah, it's fun, isn't it? Insights is a new product that we released earlier this year. It provides a whole new way to do spatial analysis in a very intuitive and interesting way, visual. I'm interacting with data Academics often call this exploratory spatial data analysis and visualization. It's a long word, but you'll see this in a few minutes. I don't want to spend too much time, but you can take any kind of databases that you have and explore them in terms of space-time patterns, charts, graphs, and this will open up, like I said earlier, our community, not only allowing you to do your work faster and better, but also sharing your work with your colleagues in other fields. On the big data side, we have been working on tools to make geoprocessing and spatial analysis faster and also scale out to the hundreds of thousands of, for example, observations, or the millions of observations, or the tens of millions of observations, or the billions of observations. Using the geoanalytic server now, we can do the space-time work that we could only do in desktops in the past at scale, doing space-time analysis, hotspot analysis, for example, looking at this space-time cube in Houston, looking at patterns through time at scale. And this kind of environment increases the performance by 10 to 100-fold. On the raster side, or the image side, large image collections like a few images or a few dozen images or a few hundred images or a few thousand images or a few tens of thousands of images can now be processed, leveraging distributed computing and parallelizing the processing. So common tasks of image processing can go on at scale and be almost immediately delivered using the architectures that I talked about earlier. Closely associated with big data is real-time analytics. Here, reading in high-velocity data streams and supporting the notion of monitoring and alerting. This is commonplace now in many organizations. They've become real-time. Using the GeoEvent server, they can bring data alive in their situation rooms. They can manage events. They can track their vehicles. They can do asset monitoring in real time. And the improvements here that we've made are scaling it up. It's one of the big and exciting things. I mean, we used to be able to, until this year, handle a few thousand, maybe up to 10,000 observations a second. And for many of you say, oh, that's really a lot. Now we can scale it up to hundreds of thousands of observations a second and millions of observations a second. The sort of connected car, or Jack, in your world, the connected truck. And analyze those streams in real time. ArcGIS has been designed as an open system, an open platform, which is interoperable and standards compliant. We do this in 3 ways. We do it by supporting the leading open standards and formats. We work closely with OGC and others, and our standards compliant with certifications. We also do it by directly integrating our product with other leading COTS product technologies, which bypasses the need to spend a lot of money to do system integration. You just buy this, you buy that, you plug it together, and it works. We're doing that with Autodesk right now. Also, ArcGIS is designed to be open. That is, open access to the data, open APIs, an extendable, well-designed architecture with components that can be embedded. We open source major components of ArcGIS and GitHub. And the evidence that this approach is important and also successful is realized in the thousands of heterogeneous, complex environments that ArcGIS runs in today.